Times in minutes that Carly spends each day on social media are normally distributed with a mean of 125 and a standard deviation of 24. Part A, in how many days of the year would you expect Carly to spend more than 142 minutes on social media? Now, if we let X here to be the times that Carly spends each day on social media, then X follows a normal distribution with a mean of 125 and a standard deviation of 24. For A part 1, you want to find the number of days that you expect Carly to spend more than 142 minutes on social media. So we need to find the probability that she spends more than 142 minutes on social media. Then we multiply this by 365 to get the expected number of days. Since X is a general normal distribution, and we want to find the probability that X is greater than 142, we have to standardize. So we change this to Z. We take 142 minus the mean, which is 125, and divide by the standard deviation, which is 24. And in this case, Z here follows a standard normal distribution. So we have to find the probability that Z is greater than 0.7083. From the standard normal table, this is 0, then we have 0.7083. This is what we need to find. But the table given is a left tail table. We can find this left tail area. We get a 0.7604. Then the area that we need to find is 1 minus 0.7604, and that is 0.2396. So the probability that we want is 0.2396. Out of 365 days, how many days do we expect to see this behavior? We take 365 multiplied by 0.2396 to get a value of 87.454. Then we say that out of 365 days in a year, we expect Carly to spend 87 days taking up more than 142 minutes on social media. Yeah, she is very popular. Part 2, find the probability that Carly spends more than 142 minutes on fewer than less than 2 of 10 randomly chosen days. This becomes a binomial distribution now. So for this case here, out of 10 days, the probability of success is the probability of spending 142 minutes on social media. So the probability of success is 0.2396 from part A. We want to find the probability that she spent less than 2 days out of these 10 randomly chosen days on social media. So to spend less than 2 days out of these 10 randomly chosen days, she either spent 0 days or she spent 1 day out of 10. That is a binomial distribution now because we have out of 10, we find the value of X or R here. Then in that case, N is 10, we have 10C0 and 0.2396 to the 0. 1 minus that, the probability of failure is 0.7604 to the 10. probability 1 day is 10C1, 0.2396 to the 1, 0.7604 to the 9. We can compute all these using calculator. So that is 0.064628 and 0.20364. That gives us a probability of 0.268 to three significant figures. Part B, on 90% of days. So for part B here, on 90% of days, Carly spends more than T minutes on social media. We need to find the value of T. So probability that the time spent of social media is greater than T, this is given by 0.9. So what we need to do now is we need to standardize. That will give us probability Z greater than T minus the mean, which is 125, divided by 24. This is 0.9. We need to find the Z score now. You have 0.9 here. So probability T greater than a value, we start shading from the right. Until we get an area of 0.9, it must pass through this midpoint. Then when you move all the way here, the shaded area is 0.9. Then this is 0.1. So what we need to do is we need to find this Z value. And this Z value is negative 1.282. Then T minus 125 over 24 is negative 1.282, or T minus 125. You multiply this right across, we have 24 times negative 1.282. That is negative 30.768. Or T here is 125 minus 30.768. So that is 94.232, or we say that T is 94.2 minutes.